Hello, hello! Here is a video going over the Algebra 1 Semester 1 Final Exam Review Packet. So this video is going to cover every single concept that you learned during the fall semester of Algebra 1. So first things first, Unit 1. Unit 1 was all about equations and inequalities. So the concepts you need to know are how to solve equations using proportions, properties used to solve equations and inequalities, solving percent problems, writing expressions in equations, solving literal equations, writing solutions to inequalities, determining if a number is a solution to an equation or inequality, as well as how to graph inequalities. So, question number 1. List the properties used to solve equations or inequalities. Hint, there should be, not 8, there should be 6. And that is a typo. Okay, so the properties used to solve equations and inequalities are basically rules that allow us to manipulate an equation. So when we're solving equations, we're able to add values on both sides, subtract, multiply, divide, and those are because we have properties of equality. So our first property, number 1, is the addition property of equality. So addition property of equality, because that allows me to add a number on both sides of an equation or an inequality. Similarly, like I can add, I can also subtract. So I have the subtraction property of equality. I can also multiply the same number on both sides, so that is multiplication. Whoops. Just going to put little quotations there so I don't have to rewrite it a million times. Multiplication property of equality. The next one, I also have the division property of equality. I also am able to distribute with equations and inequalities, so that is called the distributive property. And last but not least, another thing that I can do with equations and inequalities is combine like terms. So each one of these properties allow us to solve equations or inequalities, and we can use each one of these properties in the upcoming questions as we are solving the equations. Okay, number 2. I have my equation that I'm going to go ahead and solve. The first thing that I notice is I have a 3 in front of a parenthesis. That means I should probably distribute. So now I'm going to use the distributive property. So I have 3 times 2x is 6x minus 3 times 1 is 3 equals, and if I look on the right-hand side, I have my x's over here that I can combine. So I can also use the property of combining like terms. So 5x plus 7x is 12x plus 3. Now from here, what I need to do is I need to get the same, I need to get variables on one side, number on the other. So I'm going to go ahead and subtract 6x from both sides. That gives me negative 3 equals 6x plus 3. From here, I'm going to subtract 3 from both sides. That gives me negative 6 equals 6x. And then finally, the division property of equality allows me to divide both sides by 6. So I get x equals negative 1. So my correct answer for number 2 is B, negative 1. Number 3, I notice that I have a set of parentheses once again, so I'm going to go ahead and distribute. Now, be very, very careful when you're distributing with number 3, because not only are you distributing a 2, but you're also distributing the negative with it. So I'm going to go ahead and rewrite. So I have 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 5 is a positive 10 equals 10. Now I can combine like terms because I have my 6x minus 6x. That's going to cancel out, and that's going to give me 0x. So I have 10 equals 10. Now, I need to ask myself, does 10 equal 10? Well, of course it does. That is a true statement. So anytime your variables cancel out and you are left with a true statement, that is going to be infinitely many solutions. Number 4. Ooh, got 2 sets of parentheses. Okay, so let's go ahead and distribute. So I'm going to rewrite my problem. I have 9p minus 19 equals, I can distribute the 5 into my first set of parentheses. So 5 times p is 5p. 5 times negative 2 is negative 10. For my second group, I am going to distribute a negative 2 into the parenthesis. So negative 2 times 7 is negative 14. Negative 2 times negative 2p is a positive 4p. Okay, on my left-hand side, I can't really combine anything, so I'm going to go ahead and leave it as it is. On my right-hand side, I can combine my like terms. 5p plus 4p is 9p. I can also combine these two numbers. So negative 10 minus 14 is negative 24. And now I can go ahead and continue to solve. So I am going to subtract 9p from both sides. That gives me negative 19 equals negative 24, because my 9p minus 9p gives me 0. 9p minus 9p on the right-hand side also gives me 0. Now, does negative 19 equal negative 24? Of course it doesn't. Okay, so that is a false statement, which means there is no solution to this equation. Okay, number 5. So number 5, I'm going to go ahead and rewrite so I have some space. If I look at what's happening to my w, I am dividing by 5 and then adding 1. So I'm going to undo those one step at a time. I'm going to start by subtracting 1 from both sides. That gives me w over 5 equals 2 minus 1 is 1. And to undo my division, I need to multiply. So I'm going to go ahead and multiply both sides by 5, and that gives me w equals 1 times 5, which is 5. So my answer for number 5 is 5, which is letter A. Number 6. So number 6, I have a proportion. Anytime I have a proportion, you need to cross multiply. So I'm going to start by multiplying 11x times 5. And I'm going to set that equal to 8 times 3x plus 7. Once again, we have multiplication and distribution happening. So I'm going to go ahead and multiply. 11x times 5 is 55x. I can distribute this 8 into the parentheses, so 8 times 3x is 24x. 8 times 7 is 56. Now I can subtract 24x from both sides. That gives me 31x equals 56. I'm going to divide both sides by 31. Use a calculator for this one, since 31 does not go into 56 nicely. So I'm going to plug that into my calculator and round to a couple decimal places, and that gives me 1.81, which is letter C. Number 7, a customer went to a garden shop and bought some potting soil for $16.50 and 6 shrubs. The total bill was $72. Write an equation to find the price of each shrub. Okay, so I'm going to let S represent the price of each shrub. Okay, so since S represents the price of each shrub, that means the 6 times the S will tell me how much I spent on all the shrubs. So I have my $16.50 plus 6 times S equals $72. So let me see which equation matches that. I need to have 6 times S. Well, letter A has 6 times S. Letter C doesn't. Cross that off. Letter B has 6 times S. And letter D just looks insane. I'm going to cross that off. That one doesn't even make any sense. Okay. Now the S only goes with the 6 because it was 6 shrubs and I'm trying to find the price of each shrub. So the correct answer is going to be letter A. Number 8, solve the equation PV equals nRT in terms of R. Okay, so I'm trying to solve for R. Now, in order to solve for R, I really need to understand what is happening to R. So if I look at my R is being multiplied by N, and it is also being multiplied by T. And anytime I'm solving for a variable, I want to undo each one of those operations. So I'm going to go ahead and write inverse so I know what operations I need to do to undo what's happening to R. So to undo multiplication, I'm going to have to divide by N. And to undo multiplication by T, I'm also going to have to divide by T. Now, anytime you are solving for something, you are always working from the bottom up. So the first thing I'm actually going to do is divide by T. So I'm going to go ahead and rewrite this. So I have PV equals nRT. So I'm going to go ahead and start by dividing both sides by T. That gives me PV over T equals N times R. I'm going to divide both sides by N, and when I divide my left side by N, that just puts it on the bottom of the fraction. So the N's on the right-hand side are going to cancel, and now I have my R by itself. So I have R equals PV over NT. And let's see which answer matches that. A most definitely doesn't because it's not even a fraction. I need NT on the bottom, PV on the top, so that is letter D. Okay, number 9. So number 9, we are venturing into inequalities. So when you're solving an inequality, it is very similar to solving a regular old equation. So I'm going to start with the same process. I'm going to add 7 to both sides. That gives me negative 5x is less than 35. And I'm going to divide both sides by negative 5. And this right here is exactly when inequalities start to deviate a little bit from equations. So you need to make a note. Anytime you are dividing by a negative, you need to flip the sign. So since I'm dividing by a negative 5, my less than needs to flip, so that becomes greater than. And 35 divided by negative 5 is negative 7. Okay, well, x is greater than negative 7. That's not an answer choice, but what my question says, it says, which of the following is a solution set to the inequality? So I need to see which one of these sets satisfies this inequality of x being greater than negative 7. Okay, well, negative 10 is not greater than negative 7. Negative 9 is not greater than negative 7. Negative 7 is not greater than negative 7. but negative 6 is greater than negative 7. So right now I am looking at this set right here, and I want to see if the other values are also greater than negative 7. Well, negative 5 is greater than negative 7, and negative 4 is also greater than negative 7. So my correct answer is letter D. Number 10. Graph the inequality in relation to the real-life sample of students who spend more than $100 and up to and including $140 on a new calculator for their math final. Okay, so I'm going to underline some important pieces. They spend more than $100 and up to and including $140. Okay, so when I'm looking at graphs at inequalities, I need to pay attention to a few things. I need to see if I have open circles or closed circles. A closed circle means that you can actually include that value. An open circle means that you cannot include that value. So since my students are spending more than $100, that means at 100 I should have an open circle. So that eliminates some of your answers where 100 has a closed circle. Now, anytime you're looking at multiple choice, you should always try to eliminate some answer choices so you can narrow a few things down. And then it says up to and including 140. So since I can include 140, that means at 140 I can have a closed circle. So my answer is letter D. Number 11, solve the compound inequality and then graph your solution. So sometimes compound inequalities can seem a little overwhelming because you're looking at two inequalities at once. Now, when I try to figure out what the heck I'm going to do to solve, what I like to do is I like to just kind of get rid of one side. And as I get rid of that one side, I can use the operations that I'm going to use to solve for x to all three portions of my inequality. And sometimes covering up one piece helps my brain process and helps me narrow down what it is that I need to do. So if I look at this inequality, I have 4x minus 10 is less than 6. So if I look at this, I'm going to start by adding 10 to both sides. Now, since this actually is a compound inequality, I'm going to go ahead and erase this since I now know what I'm doing. Since I'm adding 10 to these two portions of my inequality, I also need to do it over here. So now I have negative 2 plus 10 is 8. That gives me less than. The 10's in the middle are going to cancel. 4x is less than. 6 plus 10 is 16. Now the same idea. I need to look at what's happening to my x, and to isolate my x, I need to divide by 4. But of course, if I'm going to divide the middle by 4, I need to do the right side and the left side. So I have 2 is less than x is less than 4. Okay. Well, now that I've solved my inequality, there's only one answer choice that has this as my inequality. So my correct answer is D. Now, let's say your math teachers are really mean and you have multiple choices that had this as your inequality and you had to differentiate between the graphs. So if I look at my graph, since I do not have an or equal to on either of those inequalities, that means both of my circles on my graph should be open circles, which they are. So this graph right here matches the inequality that I have. Okay. Number 12. So number 12, you bought a pair of jeans on sale for 25% off. Lucky you. If the jeans cost $115, holy cow, those are expensive jeans. It's a good thing they're on sale. If the jeans cost $115, how much did you pay? Okay, so anytime we're talking percents, one thing that you need to remember is you need to remember this expression, part over whole equals percent over 100. So 100% represents the entire thing of something. So that's why it is across from the whole. And the part is a portion of that 100%, just like the percent is a portion of 100%. Okay, so if the jeans cost $115, how much did you pay? So the $115 represents how much the jeans cost in its entirety. So that's going to be the whole. So 115 on the bottom. I don't actually know which part I'm going to take off. I'm going to take 25% off, but I don't know exactly how much that is yet. So that's going to be my X. My 25% is on top, 100 on the bottom. And now what I have here is a proportion. So I can go ahead and cross multiply. So 100 times X is 100X. 115 times 25 is 2,875. And then I'm going to divide both sides by 100. So X equals 28.75. Now, that doesn't actually represent how much I'm going to pay. This represents the 25% off. That is how much I am saving. So in order to figure out how much I'm actually going to pay, I'm going to take the whole cost of the jeans minus my lovely discount, and I am going to pay $86.25 for those jeans. Still pretty expensive if you ask me, but at least you saved some money. Okay, number 13. Solve the following equation and justify each step using properties from number 1. So I have 2 times 4x plus 1 equals 18. Okay, so I'm going to start by rewriting my equation. So I have 2 times 4x plus 1 equals 18. That right there is given to me. Okay, now to get to my next step, what I want to do, I want to distribute. So I'm going to distribute the 2 into the parentheses. So 2 times 4x is 8x, plus 2 times 1 is 2, equals 18. And I am able to do that because of the distributive property. So what this question is asking for is it's asking you to justify each step. So you need to give a reason as to why you are able to do the step that you did. Now my next step, to continue to solve, I would subtract 2 from both sides. So that gives me 8x equals 16. And once again, I am able to do that because of one of our properties, the subtraction property of equality. And last but not least, to get my x by itself, I can divide both sides by 8, and I get x equals 2. And I am able to do that because of the division property of equality. So you're just listing out the properties that coincide with each one of your steps. Okay, solving and graphing inequalities. So I have my inequality, 10 is less than negative 2x. I'm going to get my x by itself, so I'm going to divide both sides by negative 2. Now, I'm dividing by a negative, which means I'm going to have to flip that sucker around. So 10 divided by negative 2 is negative 5, is less than, oh, I didn't flip it. Sorry. Negative 5 is greater than x. Okay. So now, in order to graph it, I'm going to go ahead and put negative 5 right in the middle. I'm going to put one number on each side so I can see numerically which direction it's going in. So I have negative 4 on my right, negative 6 on my left. Okay, and my inequality is telling me that negative 5 is greater than x. So I need to ask myself, is negative 5 greater than negative 6? Or is negative 5 greater than negative 4? Well, negative 5 is greater than negative 6. So that means I'm going to graph in the direction towards the -6. If I look at my inequality, that is going to tell me that I need an open circle because I did not have the or equal to. So at -5, I'm going to have the open circle. And once again, my inequality, when I read it out loud, says -5 is greater than x. So I'm going to shade in the direction that matches that inequality. And that is everything to the left of -5, because -5 is greater than all of those values. All right, number 15. I'm going to start by putting my x's on one side. So I'm going to subtract 3x from both sides. 6x minus 3x is 3x. Minus 7 is less than 5. Add 7 to both sides. That gives me 3x is less than 12. Divide by 3. And this time I do not need to flip because I'm dividing by a positive 3. So I have x is less than 4. Okay, I'm going to put my 4 right in the middle, numbers on both sides, and it's telling me that x is less than 4. So since I don't have the or equal to, I'm going to have an open circle, and I need to find out which value is less than 4. Is 3 less than 4? It sure is. Is 5 less than 4? Nope. So that means I'm going to shade in the direction of when it was true for that inequality, which is towards the 3. Okay. Number 16, compound inequalities. So x is less than -2 or x is greater than or equal to 4. I'm going to put both of these numbers on my number line in numerical order. So -2 would be on the left-hand side, 4 would be on the right-hand side. And for x is less than -2, that is going to be an open circle. And anything less than -2, like -3, -50, that would all be to the left of -2. For x is greater than or equal to -4, I'm going to have a closed circle because of the or equal to. And greater than 4 would be everything to the right of 4, like 5, 7, 28. So everything in that direction. All right, number 17. Graph the solutions to -3 is less than or equal to x is less than 5. So I'm going to put -3 and 5 on my number line. At -3, I do have the or equal to. At 5, I do not. And if I look at my inequality, my x is sandwiched in between -3 and 5. So that means x has to be in between -3 and 5. So I'm going to shade right in between -3 and 5. Okay, last question for Unit 1. The Freshman Student Council started the year with $1,875 in their account. They need at least $4,500. I'm going to underline that. That seems important. At least $4,500 to throw the winter dance. Freshman Student Council is planning on selling lollipops to earn the money. Each lollipop sold earns the Freshman Student Council $1.25. How many lollipops X must be sold to reach the goal? Write an inequality for the problem and solve. Okay, so they're selling lollipops for $1.25 each. So I'm going to go ahead and write 1.25 times X. That'll tell us how much money they make for the lollipops. They already have $1,875 in their account. So plus 1,875. And they need at least $4,500. So at least as an inequality is greater than or equal to $4,500. And there is my inequality. So now I can just go through the process of solving. I'm going to subtract 1875 from both sides. That gives me 1.25x is greater than or equal to 2,625. And then I am going to divide by 1.25. So I have x is greater than or equal to 2,100 lollipops. That's a lot of lollipops. So that means they need to sell at least 2,100 lollipops to meet their goal of having at least $4,500 for the winter dance. Okay, so that covers everything from Unit 1. Before we move on to Unit 2, I interrupt our final exam review to tell you a joke. Okay, so what do you call a cow with no legs? Ground beef. Get it? Because the cow has no legs and beef come from cows. So he's on the ground. Ground beef. Okay. All right, let's go back to math. Unit 2. Unit 2 is all about functions. So for our unit, we need to know what a function is and how you know if it is a function when you have a graph, a table, coordinate points, or a mapping diagram. So if I am looking at a graph and I want to determine if it is a function, I'm going to use something called the vertical line test. Whoops, can't spell. Vertical line test. If I have a table, I need to check that each input has only one output. Basically what that means is that your x's cannot repeat, meaning that they cannot go to different y values. For coordinate points, you are going to do the same thing. Each input has only one output. And for the mapping diagrams, same thing. Each input has only one output. A mapping looks like your two ovals, and you are mapping or lining up numbers to numbers. So this would be your x bubble and your y bubble. And you're checking to see that your x's are going to, each x is only going to one y value. Okay. We also talked about domain and range. Domain represents your inputs, or x. Range represents your outputs, or y. We talked about evaluating functions, so that is when you are plugging stuff into your function. Continuous data versus discrete data. Continuous data is something that you have to measure. Discrete data is something that you can easily count. So for example, my height would be continuous data because you are continuously growing from when you were a baby up until you're in high school. At least, actually, I stopped growing in middle school, so I guess it depends on the person. Discrete data is something that you can easily count. So like the number of questions on your final exam, that would be discrete data. Matching a graph equation and data to its name. So we talked about our big six: absolute value, cubic, quadratic, linear, exponential, and square root, as well as reading, drawing, and interpreting graphs based on real-life situations. Okay, so first things first. Which graph is not a function? So in order to determine if a graph represents a function, you're going to use the vertical line test. And your vertical line test means you're going to draw a bunch of vertical lines. That one's not vertical. A bunch of vertical lines, and making sure that your vertical line only touches your graph in one spot. Letter A seems pretty good. That one is a function. But letter B, let's see where the issues are. Right here. That vertical line touches 3 points. This vertical line also touches 3 points. So which graph is not a function? Letter B. Number 2, true or false? The following relation is a function. So if I look at my relation, I'm going to check my x values. And what I'm looking for is I'm looking to see if any of my x values repeat. because if it does repeat, then it's probably going to a different y value, which is not a function. So if I look, none of my x's repeat. Each input has only one output, so that is true. That relation does represent a function. Evaluating functions. So evaluate f of 9 when f of x equals negative x plus 4. So this number in the parentheses, that represents your input, also known as x. So I'm going to take 9 and plug it in for x. So I'm trying to evaluate f of 9. So wherever I see an x, I'm going to replace it with 9. I can simplify. Negative 9 plus 4 is negative 5, which is letter B. Number 4, the domain of f of x equals x squared plus 2 is negative 1, 0, and 1. What is the range? So again, domain represents your x values. So what I'm going to do is I'm going to take each one of these values and plug it in for x one at a time. So I'm going to evaluate f of negative 1. That's negative 1 squared plus 2. Well, negative 1 squared is negative 1 times negative 1, which is a positive 1, plus 2, which is 3. So one value of my range is 3, so I can go ahead and eliminate C and D already. And let's calculate it when it's 0. So f of 0 is 0 squared plus 2. Well, 0 squared is 0, plus 2 is 2. So far I have 3 and 2, which still leaves me with A and B. But let's evaluate f of 1. So f of 1, I have 1 squared plus 2. 1 squared is 1 times 1, which is 1, plus 3. Oops, sorry, got ahead of myself. 1 plus 2 is 3. So that means my range values are 3, 2, and 3. So the correct answer is letter B. Now, anytime you're listing domain and range, you do not list the same value multiple times, which is why you do not see a set that has 2 3s. Okay. The amount of snowfall is represented by which type of graph? Continuous, discrete, or neither? This would be continuous because your snow would have to be measured. It's not something that you can count. There's no way you can count snowflakes and figure out how much snowfall there is. That would be insane. Number 6, the number of snowballs you make for a snowball fight is represented by which type of graph? That would be discrete because you can actually count how many snowballs you have. Okay. Number 7, as you drive to work, you record your speed at different times. Determine the appropriate domain and range. So domain, once again, talks about what's happening to your x values. Range talks about your y. So if I look, my domain should be something that deals with time. So if I look at letter A, that's talking about speed. That's not going to work. Letter B, I can drive up to 30 minutes. That talks about time. Sure. We can try to eliminate some of the answers from there, so that could be an answer. Letter C, your car can travel up to 30 miles per hour. That's not talking about time. And letter D, your domain, you can drive up to 60 minutes. That is talking about time, but if I look at my graph stops at 30. So that means that is not going to work either. So my answer is letter B. Now let's double check our range to make sure that it makes sense for that particular answer. So your range is talking about what's happening to the speeds. And the speed goes up to 60 miles per hour, which is exactly what this range tells me. It says that my car can travel up to 60 miles per hour. So correct answer is B. All right, evaluating functions. So once again, whatever is in your parentheses, that is what you are plugging in for x. However, you do need to pay attention to which function you're going to use because all of these are labeled. This one's f of x, g of x, h of x, and j of x. So you need to pay attention to what you are plugging into. So this one says f of -3, so I'm going to plug into my first function, the f function. So wherever I see an x, I'm going to plug in a -3. And then just be careful as you're evaluating. So -3 squared is -3 times -3, which is a +9 minus 4, which is 5. Number 9, j of 2. So I'm going to plug it into the j function. So j of 2 equals absolute value of 2 minus 4. Well, I'm going to simplify what's inside my absolute value. So 2 minus 4 is -2. And what absolute value does is it talks about distance from 0. And distance can never be negative. So -2 is 2 units from 0. So +2. So absolute value, whenever you're taking an absolute value of some number, it should always be positive because the definition of absolute value is the distance from 0, and distance can't be negative. All right, number 10, h of -1. So I'm going to plug into my h function. Ooh, this is a good function because it's an exponential function. I like that. Okay, so I have a negative exponent. Negative exponents mean I need to flip my base. So my base is a 3. So when I say flip, that means take the reciprocal. So my reciprocal of 3 is 1/3. And when I do make that flip, my exponent now becomes positive. From here, 1/3 to the first power is 1/3. Order of operations tells me I need to do this exponent first before I can multiply by 2. And 2 is the same thing as 2 over 1. I can multiply straight across. 2 times 1 is 2. 1 times 3 is 3. So my final answer is 2/3. And number 11, solve for x if g of x equals -10. So this is telling me that g of x equals -10. So I'm going to take my g of x, which is that -3x plus 2, and I'm going to set it equal to -10. Okay, and I can continue to solve. I'm going to subtract 2 from both sides. -3x equals -12. Divide by -3, and I get x equals +4. So hopefully you'll notice that 11 is worded differently from 8, 9, and 10. So 8, 9, and 10 you were evaluating, meaning that you were plugging in for x. Number 11, we were solving for x. So there's a difference. Okay, number 12. You decide to go to Great America, and each admission ticket will cost $45. While you are there, they have a $5 special on your favorite treat, ice cream sundaes. Write and solve an equation to find the number of times you could visit the sundae shop if your parents gave you $60. So, identify the variables. So when you're identifying your variable, you basically need to ask yourself, what am I solving for? And in this case, I'm solving for the number of times I can get a sundae. So I'm going to let x represent the number of sundaes that I can get. Write the equation. So I have to pay for the admission to Great America, which is $45, and then $5 for each sundae. So I have $5 for each sundae, so 5x plus the $45 to get into Great America equals the total amount my parents gave me, because they're super generous, which is $60. Okay, now I'm going to solve. So I'm just going to rewrite it since I need the space. So I have 5x plus 45 equals 60. I'm going to subtract 45 from both sides. I have 5x equals 15. Divide by 5. And I can get 3 Sundays. All right, how many times can I get ice cream? I can get ice cream 3 times. That's a lot of ice cream, unless they're small scoops. But it says it's a sundae, so I'm assuming they're huge. So maybe 3 might be a bit much. But you never know. Depends on the person. Okay, next up, graphs. So draw an example of each type of graph. So an absolute value is a V-shaped graph. There's my absolute value graph. Cubic looks like somebody doing the disco. Quadratic is a U. Square root kind of looks like a sideways quadratic, but just half of it. So square root. Exponential grows as you move to the right. And linear is a straight line. All right, next up, real world situation. So create 2 graphs to represent the following information. You walk away from home, you stop, you walk further away, and then you turn around and walk home. Okay, so my first graph is talking about distance from home versus time. Okay, so distance from home. If I start right here, my distance from home is 0, okay? And then from here, I am walking away from home. So here I am, I'm walking. So my distance from home is starting to increase. So that's going to be portion A of my graph. And then I stop. Maybe I was looking at a tree. Maybe in the tree was a bird, and I was looking at the bird. So I'm stopping. So that means my distance from home is not changing. I'm walking further away. So that's this part of my graph. So my distance from home is continuing to increase. And then from there, I realize, oh crap, I forgot my phone at home. So I need to turn around and walk home. So that means my distance from home is going back to 0. So that is that portion of the graph. Now, my second graph talks about speed. So if I'm looking at the speed of what's happening as I'm walking, initially, I'm not moving at all, so my speed is 0. But as I'm walking, my speed is going to increase. So my speed is increasing, but then eventually I'm going to stop, right? So that means my speed needs to go back down. So this part of my graph represents the portion A. And then when I'm stopped, I'm not moving, so I don't have a speed. So this right here is B. And once again, I am moving, and let's see, so I'm moving, and then I'm going to pause. So this is portion C, and then I'm going to pause, and I need to go back home because I forgot my phone, and I'm freaking out, so I'm going to go really fast. And then, of course, I'm going to stop when I get back home. So that is portion D. There are different ways that you can create these graphs. Your humps for the speed versus time could be higher if you're walking really, really fast, or even if you're jogging. But overall, your distance from home graph should look like this. Your speed graph may vary. Okay, so that is everything for Unit 2. And just like after Unit 1, I told a joke, here's another joke. Why don't eggs tell jokes? Because they'd crack each other up. Get it? Because you're telling jokes, and they're funny, and it's cracking you up. And if you're an egg, you're going to crack wide open. All right, moving on to Unit 3. Linear functions. Whew. Okay, so what do I need to know about linear functions? I need to know how to, from a graph, form a graph, table and 2 points. That statement doesn't make any sense. I'm assuming it's talking about how to find the slope. Slope. That would make more sense. How to find the slope from a graph, table, and 2 points. So when we're talking about a graph, that is rise over run. when we're talking about a table, that is your change in y over your change in x. And 2 points has a formula, y2 minus y1 over x2 minus x1. Okay, we also need to know how to write an equation and graph a vertical line, horizontal line, a line with a negative slope, and a line with a positive slope. We have 3 different forms of linear functions. Slope-intercept form is y equals mx plus b. M represents your slope. B is your y-intercept. Point slope form is y minus y1 equals m times x minus x1, where once again m is your slope and x1, y1 represents any point on the graph. And standard form is ax plus by equals c. And we usually use standard form to solve for x and y intercepts. Speaking of which, identify the x and y intercepts on a graph or given an equation. Your x-intercept is when you are solving for x, so that is when your y is 0. So this is your mystery. Y coordinate is 0. For your y-intercept, that is when x is 0. And you're solving for y. Okay, sketch a graph with a positive, negative, 0, and undefined slope. Label them accordingly. So a positive slope is going to be going up to the right. So this right here is positive. Negative slope is going to go down to the right. So this one is negative. Both of these, when we're writing equations, would end up being in slope-intercept form. It could be in the other forms as well, but you usually see it in slope-intercept form. For a zero slope is going to be a horizontal line. Well, that's not super horizontal. Let's try that again. That's better. So this right here is a zero slope. And when you're writing an equation for a zero slope, that is going to be y equals, and whatever number it crosses the y-axis. For an undefined slope is going to be a vertical line. And when I'm writing an equation for an undefined slope, that is going to be x equals, and whatever number it crosses the x-axis. So for these two scenarios, positive and negative, your equation should have both an x and a y. For zero slope, it's only y equals a number, and for an undefined slope, it's only x equals a number. Okay, find the rate of change using the table. So rate of change is another way to say slope. So find the slope using a table. So anytime I'm using a table, what I'm looking for is I'm looking to see how I'm getting from number to number. So if I look at my distance, I am increasing by 6 each time. And then if I look at my time, I am increasing by 1. For your table, your time represents x and your distance represents y. When I'm looking at a table for slope, that is change in y over the change in x, which equals 6 over 1. So that is going to be 6 miles per second, or letter C. Number 3, find the slope of the line that passes through these 2 points. I'm going to go ahead and label it x1, y1, x2, y2, and I'm going to plug it into the formula y2 minus y1 over x2 minus x1. So I have y2, which is 7, minus y1, which is negative 6, over x2 minus x1. Well, if I look over here, I am subtracting a negative, so that becomes addition. I feel like I did something wrong. Let me think. That should be a 4. sorry, y2 is a 4, not a 7. There we go. There we go. So I have 4 minus negative 6 becomes 4 plus 6 over 7 minus 2. So 4 plus 6 is 10 over 5, which is 2. So correct answer is B. Okay, what is the slope of the line graph to the right? It is a horizontal line, so my slope is 0, undefined. Number 5, find the slope of this line. So in order to find this slope, I'm going to look for nice points on the graph where they cross the grid in beautiful spots. And then I'm going to do rise over run. So I'm going to see how I can travel from one point to the next. And this, I'm going down 1 to the right 4. Oh, did not mean to do that. Okay, so rise over run. So my rise is going down 1, my run is going over 4. So my slope is negative 1/4, which is letter A. Michael started a savings account with $800. After 4 weeks, he had $750. After 10 weeks, he had $675. What is the rate of change of money in his savings account per week? Okay, so if we look at what's happening to the amount of money in his account, we can see that it is decreasing. So it's going from 800 to 750 to 675. So that means it would have a negative slope since it is decreasing. If it were increasing, you would have a positive slope. Number 7, write an equation of a line with a slope of 1 and y-intercept of 4. So since I have my slope and y-intercept, I can go ahead and write my equation in slope-intercept form. So my m is 1 and my b is 4. So I have y equals 1x plus 4, which is letter D. Now, if you'll notice for letter D, you don't actually see the 1 in front of the x. Usually, if our slope is 1 or negative 1, you don't see that 1 there. But the correct answer is still letter D. All right, number 8. Write the slope-intercept form of the equation for the line graphed below. So again, slope-intercept form. I need my m and my b. I just realized up here it shouldn't have said 4, it should have said b. I was writing the regular slope-intercept form. Okay, so B is where it crosses the y-axis, because that's your y-intercept. So my y-intercept is the point 0, 3, which means my B is 3. And then for the slope, I'm going to use rise over run again, so going from one point to the next. So to get from this point, I am going up, what is that, 1, 2, 3, 4, so up 4, and over 2. So my slope is 4 over 2, which reduces to 2. So when I write my equation, I have a positive 2x plus 3, which is letter A. All right. Number 9, write the equation of the line graph below in point-slope form. Okay, so what is point-slope form? Y minus y1 equals m times x minus x1. So in order to have point-slope form, I need two things. I need m, and I need any point that is on the graph, x1, y1. Let's see. Here's a point. That's the point I'm going to use. So that point is 4, 1. And for my slope, I'm going to go ahead and find another point. Let's use this one. And then to get from one point to the next, I am going down 2 over 4. So that means my m is negative 2 over 4, also known as negative 1/2. Okay. Well, all of these answer choices have negative 1/2 as my slope, so that doesn't really narrow down anything. When I'm writing my equation in point-slope form, it's y minus my y equals m times x minus my x. Now, if I look at my points, my x-coordinate was 4, my y-coordinate was 1. So I should have y minus 1, which tells me right away that my answer is letter A. So you're always subtracting whatever your x and y values are from your points to get it into point slope form. Okay, number 10, find the x and y intercepts. So to find the x and y intercepts, what you're going to do is you're going to plug in 0 for each one of the variables, one at a time, of course. So to find my x-intercept, I'm going to plug in 0 for y. That gives me 2x equals negative 18, so x equals negative 9. And right away I can see that my answer is letter D. Now let's say you had multiple answers where the x-intercept said it was negative 9. Let's go ahead and find the y-intercept to make sure that that matches. So my y-intercept, I'm going to plug in 0 for x equals negative 18. So that gives me 3y equals negative 18. So y equals negative 6, which is exactly what letter D also tells me. Okay, number 11. Are the graphs of the following lines parallel? Explain. So I'm going to make a note. Parallel lines, what it means to be parallel. Parallel lines have the same slope. So what I want to see is I want to see if both of these lines have the same slope. Okay, so the first equation is in slope-intercept form, this one right here. So I can see that my slope is 2. For my second equation, that sucker is not in slope-intercept form, unfortunately. So what I need to do is I need to get it into slope-intercept form. So in order to do that, I need to solve for y. Ooh, should have separated that. Solve for y. So in order to solve for y, I'm going to start by moving the x. So I'm going to subtract 16x from both sides. That gives me negative 8y equals negative 16x minus 8. And then I'm going to divide everything by negative 8. So I have y equals negative 16 divided by negative 8 gives me 2x. Negative 8 divided by negative 8 is 1. So my equation for the second one is y equals 2x plus 1. So my slope for my second line is 2. Now let's compare the slope from the first one, which was also 2. So let's see. The slopes are the same and the y-intercepts are different. Cool. So letter C is the correct answer for that one. Number 12. Determine whether the two representations of lines are parallel, intersecting, or the same line. So let's talk about a few things. Parallel would be the same slope, different y-intercepts. If it is the same line would have the same slope and same y-intercept. And if the lines are going to eventually intersect, they're just going to have different slopes. Okay, so let's compare the table and the graph. So if I look at my table, I'm going to look at my change in y. So what is happening to my y's? My y's are decreasing by 1. For every x, I am increasing by 2. So my slope for my table is negative 1 over 2. Now let's look at my graph. Again, I'm going to find nice points to help me figure out my rise over the run. And to get from one point to the next, I am going up 2 over 1. So my slope for the graph is 2 over 1, or just 2. So if I compare these two, they're clearly not the same, so that means they're not parallel and they're not the same line, which means they have to be intersecting, because intersecting lines have different slopes. Okay, a bunch of graphing. So in order to graph each one of these lines, we really need to understand what form the equation is in. So if I look at the first one, this is in slope-intercept form. So m is 2 and b is 3, which means my y-intercept is at 0, 3. In order to graph in slope-intercept form, I am going to begin at my b. So I'm going to begin at 3. So I'm going to plot 3 on my y-axis. I'm going to use my m to move. So from here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I like to fill my entire graph for the sake of accuracy. So I'm going to put a bunch of blue dots, and then I can connect them to make my straight line. How beautiful that is. I'm going to draw some arrows because my lines go on forever and ever. If I look at my second equation, x equals -3. So x equals -3 means I'm going to cross my x-axis at -3. X equals a number is going to be a vertical line, which we wrote down at the very beginning of Unit 3's review, which I'm not going to go back because it's too many slides for me to go back. But x equals a number is going to be a vertical line. So I'll make a note. Vertical line. Y equals a number is going to be horizontal. So I'm going to cross my y-axis at 4. So I'm going to plot a point at 4 on my y-axis, horizontal line through that point. And I can draw my arrows because these lines are going to go on forever and ever. Okay, next graph is in point slope form. So my slope is the number in front of the parenthesis. So my slope is -1/2. And when I am extracting my x-coordinate and my y-coordinate from my equation, make sure you're pulling out the opposite numbers. So my x-coordinate is going to be -3, and my y-coordinate is going to be +4. And that goes back to the fact that when you're setting up point slope form, you are using minus for your equations, because it's y minus y1 equals m times x minus x1. Okay, so I'm going to start by plotting my point. -3, 4 is right here. I used the wrong color. My first point should be purple. -3, 4. There we go. And my slope is -1/2. So that means from that point, I am going to go down 1 over 2. Down 1 over 2. And once again, I am going to fill my entire graph with points because I like it for the sake of accuracy. Okay, I can go ahead and connect all of my blue little points. And I'm going to draw my arrows because this line can go on forever. Okay. Next one is in slope-intercept form. If there is no number in front of your x, it's like having a 1 there. So m is -1 and b is 3, which means my y-intercept is 3. So I'm going to begin at my b, and my slope is -1. So what that means is I'm going down 1 over 1. Ooh, these are going to be tight points. So close together. I actually don't want to plot all of these points because it's too much for this one, since there's so many of them. I don't know why my Apple Pen's not working. There we go. Yeah, I'll just do 3 on each side. Gotta keep it even. Okay, and then I'm going to connect. Here we go. Whee! In the other direction as well. There we go. Okay. And this one is in standard form. So standard form, you can use your x and y intercepts. So for my x-intercept, I'm going to solve for x, plug in 0 for y. For my y-intercept, I'm going to solve for y by plugging in 0 for x. So I get x equals 8 and y equals -6. So on my x-axis, my x-axis, I'm going to go over to 8, and my y-axis down to -6. And let's connect. See if I can go in the opposite direction as well. There we go. That looks nice and straight. All right, and there's your graph. Okay, so that is the end of the linear unit. So here comes another joke. What do you call cheese that isn't yours? Nacho cheese. Get it? Because it's not your cheese. Nacho cheese. Oh, I'm having so much fun laughing at my own jokes, guys. It's just, we have so many questions, math questions to get through, that these jokes just make me so happy. And I love my Bitmoji in the nachos, because it's nacho cheese. All right, moving on. Exponentials. So for exponential functions, we want to write an equation of an exponential function, evaluate compound interest, and determine exponential growth or decay looking at an equation, table, graph, or real-life situation. Okay, so number 1, label each of the following tables as linear, exponential, or neither. So for something to be linear, you're looking at your y's, and you need to be adding or subtracting the same thing every single time. For something to be exponential, you are multiplying or dividing by the same thing every single time. So if I look at number 1, I can see that my y values are decreasing pretty quickly. So if I look at my 16 to the 4, well, to get from 16 to 4, I would need to divide by 4. Division is the same thing as multiplying by a fraction. So in this case, I am multiplying by 1/4. I'm going to see if that works for the rest of it. So 64 divided by 4 is indeed 16. So I'm multiplying by 1/4. 256 divided by 4 is 64. So again, I am multiplying by 1/4. So since I'm multiplying by the same thing every single time, that represents an exponential function. Okay, second table. Let's see what the pattern is. To get from 8 to 5 to 2 to -1, I am subtracting 3 each time. And since I am subtracting the same number each time, that is going to be linear. And the next one, let's see, 2 to 9 to 1/2 to 21. Holy cow, those are just a bunch of random numbers, not really following a pattern. So that is going to be neither, since there is no pattern. Okay, number 2, given the formulas for bacteria, identify the equation that relates to growth and decay. So I have b of t equals 200 times 0.89 to the t. Now, anytime I'm trying to figure out if something is exponential growth or exponential decay, I need to look at my base. If my base is less than 1, that is going to be decay. If my base is greater than 1, that is going to be growth. So the 0.89 is less than 1, so that's decay. 1.72 is greater than 1, so that is growth. Which value or part of the equation determines whether the bacteria is growing or decaying? That is your base or your b value. So exponential equations are written in y equals a times b to the x form. So that base b represents, determines whether it is growing or decaying. What value or part of the equation determines the initial population? That is going to be the a value. So in this case, our initial population is 200. Okay. What does the equation y equals 0.8 times 2 to the x represent? So again, I'm going to check out my base to determine if it is exponential growth or exponential decay, and 2 is most definitely greater than 1, so that is exponential growth. Number 4, what does the equation y equals 4 times 0.5 to the x represent? 0.5 is less than 1, so that is going to be decay. All right. An amount of $1,500 is deposited in a bank paying an annual interest rate of 4.3% compounded annually. What is the balance after 6 years? So I'm going to use our exponential equation and start by identifying A and B. So A is my initial amount, and my initial amount is the $1,500. B, I need to figure out if the amount is growing or if it is decaying. So in this case, when we're talking about interest, interest is always added to your account, so that makes your account grow. So what I'm going to do to calculate my B is I'm going to take 100% of what's in my account plus whatever interest I am accruing, so 4.3%. That gives me 104.3%. Now for B, B always needs to be written as a decimal, not a percent. So I'm going to change this to a decimal. I'm going to move the decimal over 2 units. So that becomes 1.043 for B. And then I can go ahead and write it in my equation. So my initial value is 1,500. My base is 1.043. And I want to know how much is in my account after 6 years. So I'm going to plug in 6 for x. You plug that sucker right into your calculator, and you should get letter A. Oh, time for another joke. I didn't even realize that. Caught me by surprise. What did the ocean say to the beach? What did the ocean say to the beach? The ocean didn't say anything. It just waved. Get it? Because the ocean, it has waves. Oceans don't talk anyway, but that's the whole point of the joke. It waved. All right, let's see what's next. Gridded responses. So there is a portion of your final exam where it is not multiple choice, but you're still just bubbling in answers. So this is just practice over that portion. Now it says practice bubbling in the answer 2. There are actually 5 different ways that you can bubble in 2. So the first way, which is my favorite way, is just putting that number all the way to the right-hand side and bubbling it in. So there's one way to write 2. I could also do 0, 2 if I wanted to get fancy. If I wanted to get even fancier, I could do plus 0, 2. I don't know why anybody would want to get fancy for these. I would just go with the first one. I could also do plus 2. And what else can I do? I can do plus 2 with the 2 in the middle. So just 5 different ways that you can put in 2 as your answer. Once again, this first one is my favorite because it is the most simple. All right, number 2. Now we need to actually solve, and then we can bubble in our answer. So I have this number in front of my parenthesis. I'm going to go ahead and distribute it, but once again, need to pay attention because I'm distributing a -6. Okay, so I have 9x. -6 times x is -6x. -6 times 4 is -24 equals x plus 8. I can combine like terms, just like we did at the very beginning of this review. So 9x minus 6x is 3x, minus 24 equals x plus 8. Variables on the same side. Minus 24 equals 8. Add 24 to both sides. I get 2x equals, what's 24 plus 8? Losing brain power. Ooh, 32. And divide by 2, and I get x equals 16. So that means on my response, I'm going to put 1 and 6, and I'm going to bubble in the 1 and the 6. Okay. Number 3. So number 3, I'm going to cross multiply. So I want to do 8 times 21x equals 6 times 3x plus 1. Going to multiply. 8 times 21 is 168. Use a calculator if you need to. 6 times 3 is 18x. 6 times 1 is 6. Distributing, of course. Subtract 18x from both sides. That gives me 150x equals 6. And divide by 150. I'm going to plug that into my calculator, and that gives me 0.04. So if I look at the way the gridded response is set up, I do have a decimal there. So I'm going to go ahead and put in my 0.04. And I'm going to bubble. There we go. Okay. Find the slope of the line in the given table. So I'm going to do my change in y once again. So I am subtracting, I'm not subtracting anything. I'm adding 1 each time. Over here for my x's, I am adding 2 each time. So my slope is 1/2. And you can see that I do have this lovely fraction bar already set up for me. So that's telling me that my answer is going to be a fraction. And it is 1/2. So I can bubble in 1 and then 2. Now let's say your slope was negative. You do have the option for negative values right here. So you would put in your negative right here and bubble that in as well. All right, what's next? Final review, free response. Okay. So there is a portion of your final exam that is not multiple choice. It is free response. So we need to look at this graph and use it to answer the following questions. So Megan is going to purchase a refrigerator. The graph to the right models the value of the refrigerator once she has purchased it. Use the graph to answer the following questions. What is the average rate of change of the line? Average rate of change is the same thing as slope. So what I'm going to do is I'm going to pick any 2 points on my graph and do rise over run. Please pay attention to how your axes are labeled. So my x-axis is going up by increments of 2. My y-axis is going up by increments of 100. So if I go from my first purple point to my second one, I'm going down, not 3, I'm going down 300. And over, going from 2 to 8, so I'm going over 6. So my slope is negative 300 over 6, which of course can be reduced to negative 50. Okay, what does the average rate of change mean for the given situation? My units for letter A, by the way, are dollars, since my y was in dollars. And my x is in years, so it's dollars per year. So that means the value of the refrigerator decreases, because the slope is negative, decreases by $50 each year. So that is, each year, so that doesn't make sense. Each year. So that is what the slope represents, or your average rate of change represents. Your y-intercept is where your graph crosses the y-axis, so that is at 400. So 0, 400. Make sure you write it as an ordered pair. And what does the y-intercept mean for the given situation? That means the starting value of the refrigerator is $400. So your y-intercept always represents an initial value, a starting value of some sort. In this case, we're talking about the refrigerator. Okay, what is the x-intercept? The The x-intercept is where your graph crosses the x-axis, and that is at 8. Once again, please write it as an ordered pair. And what does the x-intercept mean for the given situation? That means after 8 years, the value is 0. So after 8 years, the refrigerator is worth nothing. Write an equation of the line for the graph above. Use any form. Now for this particular question, I'm a big fan of using slope-intercept form, mostly because we already found our slope, which is m, and our y-intercept, which is b. Our slope was negative 50 that we did for part A, so that's negative 50x, plus our y-intercept we found in part C, which was 400. So my equation is y equals negative 50x plus 400. Okay, if 5 years have passed, what is the value of the refrigerator? So I have this 5 years here, and I need to figure out if I'm plugging that in for x or for y. Well, if I look back at my graph, years is represented on the x-axis. So that means I'm going to plug it in for x. So I have y equals negative 50 times 5 plus 400. And I'm just going to evaluate that. So negative 50 times 5 is negative 250 plus 400 is $150. Kelsey is also purchasing a refrigerator, and the value of her refrigerator is modeled by this equation. Negative 60x plus 600. How long will it take until Kelsey and Megan's refrigerators have no value? So let's look at one person at a time. Kelsey, her equation is the negative 60x plus 600. Now, for something to have no value, that means the amount in dollars is 0. So that means I'm going to set this equation equal to 0. So I have 0 equals negative 60x plus 600. I can go ahead and subtract 600 from both sides. That gives me negative 600 equals negative 60x. So x equals 10 years. So Kelsey's refrigerator will have value up until 10 years. For Megan, you can do it a couple different ways. So Megan's refrigerator is represented by the graph. And if I look at the graph, it has no value after 8 years. So I can just look at the graph and see where the value is 0. And that's right here. That was our x-intercept. So 8 years. Or if you wanted to take the same route that you did for Kelsey and you want to set her equation, Megan's equation, equal to 0, you can do that as well. So I have 0 equals negative 50x plus 400. I can subtract 400 from both sides. So that gives me negative 400 equals negative 50x. And of course, we are still going to get 8 years. So essentially, Kelsey's refrigerator, the value lasts longer than Megan's. All right. Woo! We did it. So that covers every single question in your final exam review packets. Hopefully you found this video helpful. Hopefully you enjoyed my jokes. I know I did. But if you do need some more clarification, feel free to rewind and watch this entire video or just pieces of it again. Good luck on your final exam. You are going to do great.